Hello students, hope all of you are fine. Today we will be studying a direct method of solving linear algebraic equations known as Gauss Elimination method. So Gauss is of course the mathematician who have introduced this method, and elimination means to find a value of a variable you need to eliminate the other variables. Okay, so without wasting any time, let's see the method. Okay. So this is our problem. I'll try to use this example. Okay. So this is basically x plus 3y plus 2z is equal to 5, x minus y plus z is equal to minus 1, x plus 2y plus 3z is equal to 2. Okay. So there are three equations, three unknown variables x, y, z, and of course you need to find the value of x, y, and z. Okay, so the first step will be to write the coefficient matrix. Coefficient matrix, as the name suggests, you need to pick the coefficients and you need to place it. Okay, so see, the coefficient here is how much? 1. So 1, coefficient of y is 3, z is 2. Likewise 1 minus 1, 1. 1, 2, 3, 1, 2, 3. Okay, so this is your A, which contains the coefficients. Now, you need to add the B. What is B? B is basically this one. 5 minus 1, 2. 5 minus 1, 2. Fine. Now, what you need to do is, you need to write a new matrix by appending B with A or concatenating B with A. Fine. So, this is known as augmented matrix. Okay. Now, so the total equations, total matrix becomes this. So this part is your A, this part is your B, and think that this line, dotted line, is like a mirror. Okay. So means if you change this value, these values by some row operations or column operations, you need to apply here also. You need to apply here also, in this column also. Okay. So let's see. So this is your first step. So you got a new matrix C. Now your objective is to make the elements under the diagonal elements 0. Okay. So remember this, you need to make the elements under the diagonal elements 0. That means you need to make this one 0, this one 0, and this one is 0. Okay, you need to make this all three 0. That means we are basically converting the matrix to an upper triangular matrix. Okay, so this is your main objective of this method. Okay, remember this thing. Or you can do one thing, you can also change it to echelon matrix. Echelon means your diagonal elements should be 1 also, and your elements under that diagonal element will also be 0. That means we are incorporating two conditions there in echelon matrix. One is diagonal matrix should be 1, and the elements under the diagonal element should be 0. Okay, but you can do this also. You can simply change it to upper triangular matrix also. You need not to worry about echelon here. You can do that also, I am telling you. So next step is, what you need to do, change the C matrix to upper triangular form. Okay, so upper triangular means, as I told you, the elements under the diagonal elements should be 0. So see, to make this one 0 first, what I need to do is, you pick this row and think it as a pivot, and take this element first as a pivot. So what I need to do is, if I want to make this 0, so 2 minus, if I made 1 into 2 here, that means 2. So 2 minus 2 is how much? Is 0. So then this row, this element will be 0. So what I can do is I can perform a R2 minus 2R1 operations and we'll change the second row. Okay, so what you get? So 2 minus 2 into 1 is equal to 0. This will give the first element of second row. And for the other elements, what is this element? Is minus 1. So minus 1 into 2R1, right? So minus 1 into 2, what is R1? R1 is here 3. This element is 3. So minus 2 minus 3. Minus 2 into 3. So how much is minus 1 minus 6? Minus 1 and minus 6 is how much? It's minus 7. So I have written here minus 7. Similarly, I have written this 2. Okay. 1 minus 2 into 2 is 1 minus 4 is minus 3, and minus 1 minus 2 into 5 is minus 10. So 1 minus 1 minus 10 is minus 11. Okay. In this way you change the second row. So basically the objective is to make this element 0. So you can do whatever you feel like. You need not to follow my process or my procedure, but your objective should be the same. You need to make this, convert this element to 0 first. You can do on the same step also that you can change this element also. That means the first element of the third row, you can change this to 0 also. So if you want to change this to 0, and if you consider this row as your main row, so I can write simply, I can minus this to write 1 minus 1 is how much? Is 0. So this will give me 0. So simply R3 minus R1 operation will yield this element is 0. So what I have done here is R3 is equal to R3 minus R1. Simply. Okay. So this will become 0. 1 minus 1 is basically 0. And then other elements, 2 minus 3 is minus 1, 3 minus 2 is 1, 2 minus 5 is minus 3. In this way you got the third row. This is the new third row. Okay, this is your first step. First step is, that means we have changed these two elements to 0. Okay, so what is left? Left is this one you need to make 0. This is your last part. So you need to change this one to 0 as you want to change it to upper triangular matrix. Fine. So for that I will suggest you no need to involve this first row. Keep it as it is. Since this row is already yielding a 0 out here, so try to pick this row, second row, and try to make some operations with the third row. Okay, so if I change this is minus 1, so if I can make this plus 1, so minus 1 plus 1 is how much? Is 0, right? So minus 1, and if you change to plus 1, so what you need to do? You need to divide it by 7. So 7 by 7 is 1. Now you need to check the minus 1, so change the sign. So it will yield plus 1. Okay, that means basically I am trying to say R3 minus 1 by 7 R2. Okay, this will yield this value to be 0. Okay, so if you perform this operation, you will get a 0 out here. And similarly, you will get the rest of the terms. So 0 minus 1 by 7 is basically 0. Minus 1 by 7 into minus 1 is basically 0. 1 minus 1 by 7 minus 3, and if you solve this, you will get 10 by 7, and this one minus 3 minus 1 by 7 minus 11 will give minus 10 by 7. So in this way you can change the third row. Fine, done. So our objective is done. That means we have changed this to a upper triangular matrix. Okay, now stop it there. Now last step is to find the value of the variables. Then how to find the value of the variables? See, your A part has been changed to a new matrix, right? And your B part has also been changed due to the row operations. So I can write this new A matrix as An. So N for new, and this one as Bn. So our process is step 3 is N into your X is Bn. Since Ax is equal to B, similarly I have written N into X is Bn. X is basically which one? X, Y and Z. X, Y and Z. So if you multiply this, so this is your An and this is your X matrix and this is your Bn. Okay, so if you multiply this, you will get these 3 equations. Okay, so see the third equation. Is 10 by 7z is equal to minus 10 by 7. So, can you see carefully, the other 2 variables are not existing here. That means they have been eliminated from the third equation. There is no existence of x and y in here. So simply we can find the value of z. Z is how much? It is minus 1. Done. So we got a value of a variable. That means the last variable you got. It is the z here. Now what you can do is simply the method of back substitution. Use this z and put it here in the second equation. Okay, so how much you will get? You will get this. Hence, the value of the variable y is equal to 2. Okay, if you solve this. That means you are putting the value of z back to the second equation to get the value of y. And the last thing is you got the value of x and z, right? So what you can do, pick that value of y and z and place it in the first equation, because there are 3 unknowns out here. So if you place, since we know y and since we know z from the other 2 equations, so we can solve x. So if you solve this, you will get x is equal to plus 1. Fine. So this is basically the method of back substitution. First of all, you will get the value of the last variable. Then you are putting back to the second equation to get the second last variable or y. And for the last equation, this means for the first variable or first equation, you need both the values of y and z. Okay, that means you are putting the z value here and you putting the y value also here. So this is the back substitution to get the values. So this is basically the method. What you can do is you can check whether our method is correct or not, whether our result is correct or not. So x is equal to 1, y is equal to 2, z is equal to minus 1. So what you can do, put this value and place it here. So x is 1, y is 2, z is minus 1. How much? So 1 plus 6 plus it is minus, so minus 2. So 1 plus 6 minus 2 is how much? 6 plus 1 is 7. So 6 plus 1 is 7, minus 2 is how much? 7 minus 2 is how much? 5. So I'm repeating once again, x value is 1, y value is 2, so 3 into 2 is how much? 6. And 2 into z is minus 1, minus 2. So 1 plus 6 minus 2 is how much? 5. That means our result is perfectly correct. Okay, it's perfect. So this is basically your method of Gauss elimination. Simply you need to change this to an upper triangular matrix. Which one to change? The C matrix. C means the augmented matrix, which contains the value of A and B together. Okay, then you need to change this to upper triangular matrix, and you can change to SL matrix also. That means you can make the diagonal elements 1 apart from making the diagonal elements under the diagonal elements 0. Yeah. So this is the method, and then the last step is to back substitute to get the value of this. You will get the value of the last variable first, then similarly you will get the other. Okay, but to get the new values, you need the other values. Okay, so see here, to get a value, say suppose z, we have to eliminate, we have eliminated x and y. So that's why the method is a Gauss elimination method. Okay, so I hope you understand. Take care. Thank you.